Good evening, everyone. Welcome to Jnanavarthini FDBPI's weekly knowledge session. Today, we are discussing about cloud security, navigating cloud security challenges and beyond. Let me welcome our speaker for the day, Mr. Praveen Nair. Mr. Praveen is a solutions architect and the program director at AdFox LLC based in Dubai. AdFox is a cloud transformation and application modernization company. Mr. Praveen has nearly 2 decades of experience in the IT industry and specializes in architecture, project management, programming, and R&D. Welcome, Mr. Praveen. Over to you.
You already gave an introduction. I'm working as a program director at Fox. It's a Dubai-based company, but role-wise, I'm an enterprise architect here. Mostly, I do the application modernization and cloud transformation here, and I do some program management as well. Who I am qualified to talk here about cloud security. I am one of the lucky person to start 2 decades back. In fact, when Microsoft launched the cloud initially, I was one of the beta tester, and I've been traveling with the Microsoft roadmap until today. I will share my experience of the cloud and giving importance to the cloud security aspects in this presentation. So I have a certification in Microsoft Azure as well. So while I will be trying to keep concepts generally applicable to all the available clouds, my examples might be biased towards Azure because on a daily basis I work on Azure. Before I delve into cloud security, I would like to know how many are already aware of this technology experts here, right? So that I can customize my talk to cater all kinds of people. I think there is a chat feature in Zoom. Would be nice if you can comment whether you have some knowledge in application software or whether you are technical or non-technical. That will help me. Could you please?
Praveen, in the meantime, I'll help you. This is the group. This is the group where they're all having a kind of diversified group. One, some of them are highly technical. Some of them are legal aspects. They are highly experienced legal. Yeah, and some of them are techno-legal, and all of them have kind of seniors in the industry. So I'm sure that they will be aware of whatever. Yeah.
Okay. So then I would go with a neutral.
Yes,
tone. Okay.
Yes, absolutely. Thank you.
Okay. So coming to the cloud, hope everyone knows cloud, and nowadays everyone uses cloud as well, at least in the form of social media, right? We post videos, photos, we upload documents to Google Drive. Everywhere it is cloud. We are in a situation where we technically do not require any local storage anymore. And it is also risky as well, right? The hard disk can get corrupted as well. So most people have some kind of drive so that on the go, you can access our files of business files as well as personal files. So ultimately, if we take the example of saving one Word document in cloud. So what really is happening, right? We need a medium, and there is always an application. For example, this Google Drive or OneDrive is always there. We cannot put the file directly without a medium. At least a FTP client will be required, or some kind of medium will be required. And cloud is not just for storing files, we know. These kind of mediums, these applications also we host.
Praveen,
Praveen, I think your voice is breaking up.
sorry to disturb you. Can you come closer to the mic, please?
Microphone is not working properly, I suppose.
Yeah. Praveen? Praveen, you are able to hear us? Yeah. Hello?
Let him check up. Let him change his.
Is he changing?
Okay. No, he's changing.
Am I audible now?
Very good.
I think
very good. Thank you.
Okay.
Thank you.
Okay. Okay. I'm not sure how much did you hear. So continue. Okay. So I was talking about the hosting part, right? So the cloud is about not just about storing files or medium or anything. It's always about applications. Ultimately, I would give importance to the application because without application, we cannot store anything, be it uploading a video or document or anything, right? So before I give, I will be giving, I will not be specifically telling you the cloud security aspects, but it is going to be a mix of how, why, when, those kind of aspects as well. Okay. So in order to explain me the cloud security, first we should be aware of how this application is hosted, because ultimately application is handling all these roles, right? So I have this. So this is a typical web application. Mostly forget that web part. We today work on either the application is installed in your machine, laptop, or the app is installed in your mobile or tablets, or ultimately you might be working directly on your browser, right? Be it SAP, ERP, or whatever. Even today, we don't require this Microsoft document or Excel applications to be installed in your machine. You can directly edit this Excel sheet, everything in Google Docs or Microsoft Office Excel 365 directly in the browser. But ultimately, we need some components to be hosted somewhere. I'm not specifically saying cloud here, but somewhere we have to store it. So what you see in the screen is a typical application. It is not a specific application, it's a generic application. Take the case of any application, the structure will be somewhat similar only. So the left side, what you see, the client side is the your part, the front end, which you will be using to browse that application. And technically inside the server, wherever it is coming from, there will be a front-end layer. Technically, if I have to tell you, HTML, CSS, JavaScript, on an advanced level, it could be a React application, Angular application, Vue application. So many frameworks are available. Doesn't matter. We see only this front-end application. Okay. But internally, what is happening is a enterprise application or a distributed application typically will be connecting to a backend system. Usually it will be a business layer or a data layer, or business layer, then business layer will be communicating to this data layer. And this data layer is the one physically connecting to a database like SQL Server, MySQL, PostgreSQL, etc. Just if someone is non-technical, just keep in mind this is the high-level structure of an application we are going to take as an example for hosting. On a delving further, this is a little bit extended view. You can see some firewall, proxy wall, then web server, these kind of things also came. Okay, and looking at another set of applications or servers, you have some APIs. You don't have to really know what these are. Why I am using these terminologies, I will be using it further as well, and will be trying to give you an idea what it is as well. So there will be some layers and tiers as well, then some advanced. Okay, but if you dissect again, delve into this architecture again, this will be little bit complex, right? So if you are technical, you will be able to relate this VMware virtual machines, some cache database, some CDNs, cloud storage, right? Now, when it comes to the deployment aspects, the infrastructure aspects, it is going to be a little bit scary. This is the same one we saw here. Okay, the abstract view. This is what really happening in the cloud. So more and more components came that maybe you will be able to relate this firewall kind of things, right? Maybe NAT gateways, elastic load balancing. This might be advanced, but this is the real picture happening in the background. This architecture diagram is from this AWS, which is a cloud provider. Somewhat equivalent can be this one. This is for the Azure cloud. Okay, almost similar equivalent functionalities here as well, but doesn't matter. My intention is just to tell you that there is something complex things happening in the backend. So ultimately, when we say cloud security, this can be in our local computer as well, but why this is in cloud is because of many architectural properties, such as maybe the size of the application, the number of people going to access this application. Maybe it's a huge, right? To give an example, a web server might be able to handle only, say, 1,000 users. What will happen if 1,001 user, one more user is added? That server will not be able to provide the service. Maybe see, website will not load, or you will get a error message, timeout or something. So then comes the load balancing feature. So multiple servers will be involved for the sake of scalability and many other aspects, including especially this security. So more and more components we will have to add. That's the thing which makes this architecture complex. So the applications for banking, finance, audit, these are all huge systems. In fact, it's not a single application, it's always a distributed application. Okay, multiple servers, multiple clouds, say multi-cloud applications, or a hybrid cloud architecture will be required. So when we log into a banking site, we see only a small interface, right? But that might be always a complex architecture. We might be seeing different widgets coming from different micro front ends and micro services. Okay, so now we can go to the cloud aspects. Quickly, I will give you the type of clouds and all, so that you will be able to relate when we talk about the security aspects. So there are different types of cloud. So you might have heard about the private cloud, public cloud, hybrid cloud, multi-cloud, and some custom clouds. Other clouds are also available. That's not relevant when we talk about the enterprise applications much here. So private cloud, we can say traditionally we used to have servers inside our application, our offices, or our own data centers if it is a big companies. We used it to manage, and then later we started calling it private cloud and all, because cloud specific features came into these local infrastructures as well, but still it is relevant. And today we have formally calling private cloud when we use the real cloud features in the private infrastructure as well. For example, Azure Stack or Azure Fabric is available. It's a a portfolio of tools which you can install in your local premises, so that whatever you get in the public cloud offering, you will get here as well. That's the idea. Now comes the public cloud. That's what you see at the right side. There are tons of cloud today available with the different properties. A few of the major cloud providers is Azure, AWS, Amazon Web Service, then GCP from Google. Then the last one you see is Alibaba Cloud. So Alibaba, maybe you may not see much because of this China, made in China, that data privacy issues and all, but it is one of the biggest in the world still. And now going to the features. So each cloud is providing different category of services. Okay. So now quickly let me say this IaaS is about infrastructure as a service that we can relate with our traditional way of hosting the applications. So if you have a website, you will be hosting in a web server hosted in your local infrastructure, private cloud or something. The same functionality without much advanced knowledge you can do in IaaS provided by Azure, for example. So it's technically a virtual machine. You can consider it as a replica of your local machine. So in your local machine, your laptops, right? You can easily convert your laptops to a web server. There are inbuilt tools like IaaS, internet services are available, or open source Apache HTTPD is available. So if you install, you can expose your laptop. You can host your own website, and if you have a dedicated internet connection, your neighbor can open your website in his browser easily. But it's not recommended way. So IaaS is all about that. You can do the same installation, everything, hosting everything in cloud using IaaS services. Now, PaaS is a little bit advanced stuff. Partially, it is managed by the cloud provider itself. So when you install web server in your local machine or local server, you have Windows or Linux installed already. So, security aspects, or whenever some security patch comes, a user machine usually will alert you there is a Windows upgrade available. Should I update or not, right? But in the case of server, no one is sitting in front of a server always. So we need some mechanism to alert. We have to enable that. But if we use IaaS, it's our responsibility to manually manage these kind of updates, everything. And it's much complex than that. If our application is not made in a secure way, we will never know someone is hacking, someone is stealing our data or not, right? So that's when PaaS comes into picture. The half the pain, it will be managed by the cloud provider itself, like this Windows upgrades and all. And it gives much more. You might have heard about few latest technologies like Kubernetes, containerization, microservices, nano services. So these concepts, even though we can do this in our IaaS as well, this management overhead is very high. But if we leverage the platform as a service, PaaS services already provided by the cloud, then it's not even half. It's at least 70% of the work is already done. We just have to host the application, and all these patches, the monitoring, if someone is trying to attack, DDoS attacks, for example. So automatically everything will be taken care by the cloud provider itself. Then comes the SaaS. We don't have to worry anything technically, because we don't need a administrator to configure services for us or anything. It's just a subscription kind of thing. To give an example, Jira is a Jira Cloud is a issue tracking tool used by most of the companies recently. So you just sign up for an account, you create projects and run the show. That's it. You don't have to worry about how much memory it has, what is the infrastructure, what is the scalability, that kind of stuff. We don't have to worry. We just have to pay and use. Okay, so we have much more AAS stuff like a database as a service, AI as a service. So many stuff recently coming into picture, but still these are the base. This never changes. Now we have a another type of cloud also available that is specific to the sectors or regions. For example, US government has this Azure government, which individuals cannot buy, only government organizations can host, and the security is also very high because the US defense people are guarding their data center regions, and all. No one will be allowed to enter into that premises and all. Similarly, the services are also limited. So whatever they are sure 100% secure, only they will be exposing to use as well. G42 is the UAE based, Middle East based cloud. Most of the government projects from UAE goes G42. Now comes the CSP. We already, in fact, mentioned this Azure, AWS, Google, and all. So these are all the popular ones. There are many. I just quoted a few the major ones. That's it. And then we have few other cloud providers as well, because not all cloud is about application hosting, right? Like we said, the document hosting. So Dropbox, the Adobe Creative Cloud, Salesforce, this kind of clouds are also available, Google Drive and all. So that's a different type of cloud. There we cannot host our applications. So we don't worry about application security aspects as well there. So different. The last category cloud, we really do not have much control over that. So whatever security measures they enforce, like MFA or SSO, multi-factor authentication, or this SMS authentication, that those kind of security measures, if they impose, we can leverage that only. Still, if someone steals our mobile phone and try to access our files, we have no choice. Okay. So before we move to the next session, shall I ask you if someone has any doubts, or should I be skipping these basic topics, or we can directly go to the cloud security? Would like to hear a feedback.
I think absolutely fine, Praveen sir. You are going
Okay.
good. I'm sure
Okay.
others would agree with me. Yeah.
Thank you.
Yeah.
Okay. Now, for the benefit of saving time, I'm not explaining any of these. These are actually scenarios. Breaches happened in last some 2-3 years, right? So with the inception of cloud, always there are security incidents happening, hacking, cracking, everything. And it's not just about cloud. It's a two-edged sword, actually. It's the people problem is also there, right? Like I said, if someone steals a mobile phone, we cannot do anything, right? So we cannot do anything immediately until we know that someone stole it and they might use for some evil purpose. Now, after this session, I will share this PPT. So if someone is interested in knowing more about these breaches, you can Google each one. So now this is about July 2013. This month, just this month, right? So many things are still happening, and no any cloud is safe, unfortunately. So if someone says its cloud is secure, it's a myth.
a chain is only as strong as its weakest link. We don't know where exactly is this weakest link. These cloud providers, whatever they can provide in terms of security and other features, they will give. So ultimately, it's the person or people who are handling that, the technical people I'm talking about basically. So when we get a fresh cloud account, so ultimately all the pods, all the loopholes will be closed already, but it's us. We will be technically opening it to the public. So to give an example, virtual machine, our IaaS service, right? So virtual machines, once we create, we will be creating it for some purpose. In a work environment, we might be giving this virtual machine VM to one of the developer, for example, in an IT company. So what kind of security we require in cloud is, after the VM is created, in order for the developer to access this VM, we need to do a small configuration, IP whitelisting, for example. Okay. We have to mention that IP. I'm just taking an example. Okay, always there are multiple ways we can regulate this. So I'm just taking one example, the IP whitelisting. So what we will do is we have to whitelist the IP. But unfortunately, because of COVID, most of the people are still working from home, right? And people bring the laptops to home, and also they might be using their personal laptops as well. And this internet at their home may not be having a static IP. It will be dynamic. Whenever they restart the router or every day, they will be getting different IPs. So whitelisting a single IP is not always practical. So what the administrator will do as a jugaad is, he will give a range like 0000 to 255.255.255.255.0. What will happen is, anyone in the world can access this VM if they somehow gets the username and password. So ultimately, cloud is strong, very secure. It is giving 99.995 percentage security and the high uptime, everything. But what our administrator did is the wrong thing, right? So he should have found some other way to do that. For example, VPN is one way to do that. So it is all about designing how they are going to work. And another aspect is this, even after taking all the cloud measures, if the application which we are using has some flaws, then there is no point in that security, right? So I still remember some 7-8 years back, there was one web application. In fact, there was a contact us form, and there was no capture facility was also not there. After hosting that application, 1 week later, we found that we started getting spam emails. And after inspection, we about some 10,000 attempts were there, and most of the mails went to spam as well. And upon inspection, we found that one of the URL used internally was exposed not just to this website, but anyone can access. And unfortunately, it was using an email gateway which was paid. So a company had to pay too much money covering those expenses as well until we fix that. So this application security, it's not just about the developer task. Developer, due to different reasons, work pressure, everything, and knowledge issues, he may not be implementing such a feature. But the penetration testing, right? Those kind of things should be implemented as a policy in the organization. before we releasing that to the cloud or wherever it is applicable to any kind of infrastructure. In fact, when it comes to cloud is a very costly affair. Nothing is free. You will get some trial account which legally you cannot use for commercial applications. Even if you use after some, there will be a cap of some $200 or maximum one year. It will get expire, and obviously you will have to start pay. And different types of payment models are available, but obviously it's not cheap. It's much costlier than we host in our local infrastructure. Now, social engineering is a threat that, again, I want to repeat that part. So how much stronger our security, our application, or our cloud, or our infrastructure is, social engineering. That is a very big thing. Someone can talk to you. If you will tell them your date of birth, they will guess the rest of the things from your LinkedIn or social media posts. They can get into this cloud or wherever they want and get the information what they want. So there is a limit. We can block that. So some systems, such as this banking applications, after 2 or 3 attempts, they will block your credentials for a few minutes or a hour or a day. But still, expert hackers, they will attempt that only once they get the clear information. So we need to keep that in mind. So proper audits can help or reduce that at some point. So these are few major aspects. Okay. So most of the things I'm sure you know, but I will give an overview of them. So, and most of the things are about unauthorized access. Okay, somehow they will get access to your system using different ways. It may not be through the front-end application. Okay, they might be going directly to the database or database layer or business layer, or some expose the API. Okay, they will get access to the system, and they will steal the data. If the problem with these APIs are, if there is a modern API system called RESTful services, right? So it can delete the records, it can update the records. It's a major thing. So data breach, I already covered. If somehow they will get the authentication mechanism or some access. It's not just about getting password and username. It's about the roles as well. Every system has normal users, the viewers, contributors, administrators, right? So the same user, by changing one flag, might get administrator privileges. It is very dangerous. So through that way, they can gain access, and always these hackers use some kind of proxies or onion proxy systems. So it is difficult to trace them as well. Now, misconfigurations. This is something kind of accidental. So this can be resolved using some audit systems by most of the enterprise organizations have a division called enterprise team. Okay, they will not allow releasing the applications to cloud or anywhere without passing their checklist, audit checklist. So this misconfiguration is one of them, and you might know the OWASP, right? That is some standard used for application development. So that is also a checklist, and most of the applications, the scanners, security scanners, follow that OWASP tools as well. So if that passes, most of these problems will be over. So this misconfiguration is usually happens due to junior engineers, cloud engineers, or accidentally for testing purpose, we might have enabled some configuration and we forgot to restore it back. So it happens in the industry always. So we always make sure the configurations are not in a wrong manner. It is not exposing anything outside. So the next one is about insecure APIs. The APIs, it's not too old as well. We had monolithic applications. Now we have the microservices based applications. The API is I gave you an example of that email sending, right, from the contact us form. So the email might be an API. So that will be hosted in a single server. So multiple applications can consume this API. Only thing is we will be having some credential system, usually a crypto token to be sent to the API for authentication. So, but some vulnerabilities can lead to bypassing these kind of APIs, and people can use these APIs for unauthorized process, and they can access the data, delete the data, they can, whatever possible, they will be able to. So if they gain access to the DB directly, they can make some changes there so that any API without altering anything in the API itself, they can do all these mischief stuff. Next, the DDoS. It's a denial of service. Most of the cloud providers has built-in mechanism to block that DDoS attacks. DDoS attacks usually is about sending too much requests from different servers or different clients, and technically by overloading the server, and server will freeze. Ultimately, it will start to give some 500 internal server error or timeout. Nowadays we don't see much, but still exposing some APIs or some ports, some endpoints to outside world is giving someone to play with these ports and simulate these attacks. We can easily prevent them by some kind of audit. Then insider threats, it's nothing to do with technology. It's if the employee actions, right? You might have in a conference call, it happens. You will be writing the common username and password for one of your colleague, and he will forget to take it, and that post-it will be in the conference hall. Someone else will take it, right? Take a photo of that, and that can happen. This social engineering stuff, kind of, that only the organization level policies can help that. Now, I will unauthorized access stuff, I will skip. Now, malware and ransom, it's again the unauthorized stuff only. It is the one actually opening the door, right? Somehow these people has to get access to inside the cloud system through email or anything. Maybe you will be opening some zip file without knowing what is it inside, and have some macros, okay, or through directly through some directory listed some web server. So nobody exposes the folders of web servers nowadays, but still juniors tend to do that kind of accidents. Again, an unauthorized use. This is a modern kind of thing, cryptojacking. What it is about is, nowadays cryptocurrencies, the Bitcoin kind of things, and there are tons of currencies floating around, successful and not successful as well. Many people use their own hardware, not necessarily computers, but some devices with microprocessors to mine the coins. Okay, so some people are very intelligent. They, in addition to using their own machinery and their own computers, they will try to use the compute power of other machines as well. So this is not just about cloud. Maybe if they get access to your laptop, they will install a tool in your computer without your knowledge. It will start to mine the coins and all for them. But in the case of cloud, it is very more dangerous in terms of cost as well, because Azure is costly. So compute power is also costly. There is always a limit, right? So much impacts are there. Next one is man in the middle. So this is a kind of silent killer. You will never know there is a breach happened, because between your application and the server, they will be installing some kind of tool, some proxy tool. So all the requests going from your laptop or one server to another server will be filtered or will be passing through this man in the middle tool. It will be catching all your credit card information, everything, and will be sending to the person who is controlling that, and he will get unauthorized access to their systems. Now, again, insider data leakage, it's internal problem. Cloud service provider breaches, that is something we may not be able to control. It's a Azure, AWS, everything. They regularly do this audits, everything. Whenever they come to know about some breach, they will update their servers without even informing us. Okay, so internally that is happening. So some major stuff they will publish as PR as well, because a later point of time, it's a business politics as well. If we come to know at a later stage, it will be a problem for their business. And minor things we will never come to know as well. So especially if it is a hacker attempt, definitely this hacker is going to publish the information later to get credit. So it's not good for the business, right? And then finally, the application specific. At least 50% of the problems are application specific. So the importance we are giving to cloud should be given to the application as well. So no matter how secure it is. So every time when for IT companies, when we release a new version of the same application, it doesn't matter we did a security scan last time when we released. Again, we should be doing new bugs, because like we said, the cloud service providers might be upgrading their applications, and it can have impacts for our applications as well. So we never know. So ideally, it should be a part of the release cycle that I will explain when that portion comes. Now, on a random level, I will explain you some important things we should be keeping in mind. So this is one important thing. There is something called principle of least privileges. Okay, so when we give access to someone or some service or some device in the cloud. Okay. I am not watching the chat. If something need to be explained, please feel free to open the mic and tell me. Okay. Okay. So when we take an account in any cloud provider, it will be a kind of a whiteboard. So there won't be any security assigned to anyone. Okay, but whoever joining the cloud as an administrator will have full privileges as well. But we have to keep in mind that whenever we give some privilege, for example, in an application, we have a database, right? So if, well, again, it's a little bit wider topic. So when we create an application, when we develop an application in an IT environment, there will be different types of servers we will be using. The development server will be there, where our developer will be doing the coding, creating the design of the application, this front end, designing the database, everything. Now, once the application is created, he will be pushing that applications to one QA server, where the quality control people, basically the testers, will be testing the applications. And then there will be a staging server where it's almost a replica of the final public website. Okay, but there won't be much data. Real data may not be there. Then finally, after this all audits, everything, this security scan, everything, we will be pushing that to production. So technically, there will be 3 or 4 stages always. So here again, coming back to that principle of least privileges. So it's a rule of thumb. So when we give permission for database, ultimately this developer has to design a database to work in the application. So how will he design the database without having the sufficient privileges, right? So what administrator will do is he will give some contributor permission to this developer. A developer, and since he is doing in a developer environment, small companies and medium companies tend to give admin privileges to reduce the job of the administrator. And in most of the environments, this from that stage itself, organization should be having some controls and policies enforced around that. Okay, ultimately, going from one stage to another, we have to make sure the developer should not be getting access to staging or ultimately the production systems. So always give minimum permissions required. Database was just an example. It applies to any people, any device, any application. Okay. So there is a concept of the service principle of managed identity. Again, going back to our database example, in the production environment, where if you are accessing a banking website, there is no reason for you to directly go access the database physically, right? So you will be interacting always with the front end. So a person do not require access to the database. That's when we will use this managed identity, service principle, service account kind of concepts will be enforced. These are not people. Even if outsiders get some credentials for this, first of all, there won't be any passwords. And even if they get access to these kind of things, they will not be able to access directly to the database. That's the concept. But otherwise, if it is a person, there will be a password. Somehow there will be a loophole to access the database directly. So it is about isolating the unwanted stuff from the public. Next, again, the role-based access. Again, technically I explained that already. So if the developer is designing only database, then he doesn't require admin privileges. The database is already created by the administrator. So he needs only some that particular database admin privileges. The entire SQL Server or Oracle admin privileges he does not require. That's what our role-based access control is all about. Then the multi-factor authentication, it's about that. OTP authentication, for example. So in Office 365, if you try to log in from a new machine, email access, it will if the MFA is enabled or 2FA is enabled, then it will ask for an application authentication. Maybe there will be an application installed in an authenticator application installed in your phone. You have to approve that, then only you'll be able to log into that. That's what multi-factor authentication is about. Then the API microservices, the throttling part. So the cost problem I told you about, that SMS thing, right? So if the throttling was enabled, there wouldn't be any problem of that over cost problem, right? If we can limit, say the API can be used only some 1,000 times. So when someone is trying to access after this 1,000 number, then automatically the API will get blocked. So that's again a business decision, but still the organization should enforce those kind of policies. Data security is a little bit bigger topic actually, but on a high level, so we have to make sure the data is encrypted. It's not just encrypted in the database. Make sure it is the transit start itself. For example, if it is a website, you are entering your data. When you submit, the data is going to the server, right? That use the TSL or SSL encryption methods. It's already used by all the websites nowadays, wherever finance or banking is there. But still, there are much more mechanisms we can use. We can use programmatically obfuscate or encrypt this sensitive data before sending, or we can use also tokenization methods, and including the transit and the storage, we can implement that. Nowadays, most of the databases also support inbuilt encryption, so we don't have to programmatically encrypt and store. Previously, it was the situation, you will be getting some, say, plain password, you will be encrypting using some algorithm like MD5 and save it. This major encryption keys or algorithms, it is you can reverse engineer. There are tools available in the internet, and there are online services. You just copy paste and you'll get the password. So it's not anymore an issue. And today we have row level security, column level security aspects also present. It's mostly about the database. If you have an important database with tons of data, TBs of data, but each user requires only a subset of records, right? So even if he gets access to the database using his own credentials, he will not be able to see or access the values from other people, because it is blocked by the RLS CLS feature. It's not just in the database, it's in visualization tools like Power BI, Tableau, those also supports the same. The managed instance concept I already mentioned somewhat. It's kind of managed identity part only. So this in cloud, most of the PaaS services can leverage the managed instance facilities. For example, SQL Server managed instance. So you cannot access directly using some credentials. Always you will have to go through some IAM, identity and access management enabled route, which is much more secure. That's my point. This like I said again, data security is a very big part, and most of the business applications, the data is the big part, right? And especially we have now the big data, the tons of data being added every day. So whoever interested, I think I will be able to share some URLs for further reading. Now some cloud specific features. So There, see, previously in for the applications, see, there, for example, there will be connections to databases. So what developers do is there will be a connection string concept. A connection string consists of a server name, database name, the password, username, protocol, those kind of things. This we will keep in plain text file along with the project file. So usually these passwords or at least the username will be open to public, and or like I said, some weak algorithms like MD5 will be or SHA will be used. Now with cloud, we have the concept of the key vault. Okay, for Azure there is a Azure key vault available, and for AWS there is a or GCP there is a KMS available. So equivalent is available across all the cloud providers. So these certificates are about digital certificates. So key certification for certificates, any kind of sensitive data, you can leverage this PaaS service to store. So applications do not have to store plain sensitive data anymore. Now, again, the application configuration part is also available. Even though it's not so sensitive, the applications we are leveraging file-based configurations, it will have the server details at least. Or if some payment gateways are there, the whitelisted IPs, everything will be saved there. So those things we don't have to save in the files anymore. Azure or any cloud PaaS has that feature. We just put all the details there. It will be encrypted and it will be guarded by the managed identity. You can leverage in your application. So you don't have to ship those details anymore with the package, installation package. Network security, this again a little bit wider topic. So on a high level, in Azure, basically it's about what is necessary to be exposed, only that much to be exposed. That's the idea. So it could be an application, it could be a API, it could be a VM used by some VDA used by some developer, right? So some effective strategy need to be implemented, such as some virtual private cloud connected with some express route or VPN. Many technologies available. Each cloud has its own method of implementation as well. But the from a high level, the concepts are common, like this firewall will be there. Web application firewall will be there. This CD for CDN front end will be there, and some some intrusion protection systems. Everything will be there. That I will show you in Azure portal how this it can be leveraged. In fact, and ultimately, do we have time? Or are we good?
Yeah, no issues. I think you can complete it. No problem. Yeah.
Okay. Thank you. So this secure application development, again, this is at least 50% is in the developer architect, application architect, those hands. So it's a very wide topic. In fact, it's about the security by design, I would say. So when you start designing the application itself, you have to make sure you have considered all the aspects of this security. Towards the end, it will be a rework because there will be source code changes. Everything will be required for especially the APIs, right? So especially this API is unable to handle this tokenization and all. It is going to be a rework. So when you start the planning of the application itself, you should be keeping in mind developers are going to follow the quality code standards. OWASP, everyone knows, right? This is very important. nowadays, .NET, Java, Golang. So these kind of applications handle cover most of the aspects, but still there are problems. Like, for example, MVC is a architecture style. Okay, so if we are not just talking about the new applications which we are designing, right? There will be old applications as well, which will be using some kind of old libraries, right? So we have to frequently audit, occasionally audit these applications and check if some old libraries or frameworks are used, and especially the cloud administrators and engineers, they should be subscribing to the newsletters, security newsletters. Azure, GCP, every company provides, whenever you take a major account, definitely you are going to get a alert whenever there is a downtime or security breach happened or some upgrade is going to happen. And or if, like I said, if it is a VM, you may not be able to automatically do the upgradation. You will have to ask your developer to do that upgrade. So that kind of information you will get from these kind of newsletters, or someone very much interested in security or the cloud aspects. Technically an evangelist who is monitoring these major news in social media, like Reddit, Stack Overflow, that kind of websites, or these blogs. Microsoft is having security blog. So if they are subscribed, they will get information, and they will be doing that. Even if there are many security scanning, penetration scanning tools like Burp Suite and all available, but we cannot guarantee they are also updated, right? So they might miss. So loopholes are everywhere. So developers should be aware that at least the OWASP, it is not just top 10. There are many recommendations, but I've seen that people are giving importance only for 10, the top 10, which was released in 2017, in fact. But at least if we are concerned about 10, it makes a difference for the application. And then comes the latest technologies like the orchestration, Kubernetes, container, everything came. So the security aspects related to that also we have to give some focus. Then comes the DevSecOps. Still, we use the term DevOps as an umbrella, but DevOps basically is about just planning some CI/CD, the packaging of the application and sending to the compiling it, building it, and hosting it in a server, in a pipeline. People used to do that manually in the past. Now this DevOps is doing it automatically. Some job cut happen, but it is a good thing. In less than an hour, the application will go live. DevSecOps is purely about the security plugins. So the security scanners, I said, right, and code scanners, code quality scanners like SonarQube. These kind of plugins we can configure in DevSecOps tools. To give an example, Azure DevOps is a DevOps tool. It can handle these prerequisites. Like if we set, for example, Fortify scanner, okay. If that scanner is included, it's a pipeline. It will fetch the source code from the development server repository. It will compile. It will build. Building is the process of converting it to binary, then pushing it to development server first, okay, and before putting it in the developer server, then it will do the static and dynamic scanning. In fact, source code also will be scanning, and the application also will be getting scanned for this OAuths related vulnerabilities. So at any point, it's not just about security. Any point, if some a problem happens, it will stop the pipeline and give the report to the concerned people, developers, and all. So if there is a security breach, we can configure whether it is a high priority, low priority, is it just a warning of, or is it a critical one. So based on those rules, it can stop the build. So it will never be published to production or the development environment. So that's the concept of this DevSecOps. So if the organizations are not using, as part of organization policy, we should be enforcing that. They might be using already DevOps. So we have the room to ask them to use this security aspects also to be included. Now, this compliance, governance, legal, most of the things, it's about cloud platform already supports most of these things. Again, there are n number of compliance and policies, rules, protocols available, right? So before you go and recommend a server or going to audit a cloud server, so you have to understand whether any of these complaints are already available in this cloud or not. So one of the URL I provided is for Azure Cloud. So similarly, all the cloud providers will have a similar page. So see, whatever complaints they have listed here. Okay. For example, if we take PCI is here. PCI is for the credit card complaints, right? So it is supported by this Azure Cloud. So this now this is the cloud part, but still the application aspects is in our hands. So you will have to manually audit, or you have to use some source code scanner tools to check whether this kind of compliance is available or not. Next thing is third-party certifications. If it's again an organization policy or a customer policy, some ISO certification is required in order to implement that kind of stuff. And legal implication, this differs from country to country, region to region, and all. For example, if I take the example of our UAE government projects, we have a rule that all the data centers or servers should reside within UAE itself. That's how this G42 came into picture. Or take the example of Azure. There are some services available. There is a data center. There are 2 data centers in UAE, but some services are available in UAE, some services not. So when you design a website, you have to make sure that the Azure services which you are going to use is available in that region or not. So that kind of implications. It is again a design aspect. So once we design the completed development of the application, when we go for the final user acceptance test UAT, they will find it out, and that is going to be a rework again. So this Sentinel is one incident response thing. It's one of the major as per the Gartner chart. So I will kind of skip this. These are some advanced tools used by not just the cloud, but these things got importance with the introduction of cloud only. Microsoft Sentinel is one of the tool which we use for it's not just for the applications, it's for the entire infrastructure, the cloud-based security, incident, and event management. It's much more than security, I would say. Now comes the monitoring and logging part. So it's about the audit trail as well. So like I said, some applications are silent, right? So we will never know if there is a proxy installed by someone who is stealing data. The application will work without any issues. So those kind of things, if we have some kind of monitoring and logging system, we will be able to, through some incident reporting, whenever some breach happens, the infrastructure should be capable of sending a SMS or email to the administrator notifying that some suspicious activity is happening, please have a look. Or on a second level, we can even stop that service immediately. Some serious breach is happening. It depends on the severity we are setting in that application. There are inbuilt cloud features available like Azure Monitor. It's available for the infrastructure as well as the applications as well. There are few small plugins available which you can ask the developer of the application to install that in their program, so that it will frequently send the monitoring data to that associated repository or database, and regular audit will happen as well. And it has beautiful visualization reports, everything. So it will give a high level blueprint of what is happening in terms of security, the traffic, and it gives much more the performance, scalability, those kind of aspects as well. And based on the custom requirements, sometimes customers will not get satisfied with the inbuilt functionalities of this Azure Monitor or CloudWatch of AWS. They can go with the advanced tools. These are paid tools and open source tools. Prometheus, Dynatrace, Datadog. These third-party tools also you can use. So it's kind of open. When you use a cloud, you are not limited to just using that cloud. You can extend the functionalities using third-party softwares as well, and also the open source software as well. So now going to some best practices, we are going towards the end actually. So enforce security policies, we need a governance team. The organizations need data governance team as a separate team. In fact, I would say at least as a sub team of the main team. The enforcement of policies, then we have to make sure the data is encrypted. It's not just about the database, be it any service, API or any service, VPN or anything. We have to make sure that the data, be it in transit or sitting idle in a database, it should be encrypted. And MFA should be enforced, and strong passwords should be used. So people still use easy passwords like hello123, and most of the websites accept as well. And but at least our applications and cloud services, cloud has this configuration features available. What type of passwords let your employees use. So make it strong always. When we say strong, it is about just adding some extra characters, numbers, capitalization. So that kind of rules we can add. Firewalls, IPsec, anti-malware. There are built-in facilities available. It's just a matter of enabling it, but the infrastructure and the application architect, cloud architects must be aware of that as a policy of the organization as well. So the cloud backups, it's a silly thing. In fact, still there are websites taking the backup and storing it in the root folder of the website itself. So if the public access to the directory is enabled, you can directly access this file and download it. So those kind of mistakes should be avoided. The data location visibility. it's about the data center, data region visibility and control. If you do not want the data to be accessed outside of India, for example, so you should be controlling that through the configuration. All the features are available in the cloud. Enable logging and monitoring, explained already, is principle of least privileges. Keep software up to date always. Be careful about what data you store in the cloud. So cloud security solution, if the inbuilt security solutions are not enough for your organization policies, evaluate and explore the third parties available. Again, most of the things we already covered here. I think we are good. I will quickly tell you some of the features, security specific features available in this Azure. This is Azure portal, okay? So you can log in to the portal and see how it is configured, but because we don't have time, I'm not going to show that. So the left side, these are the types of services available in Azure cloud here. Security is a separate category itself. So you can see the app configuration, I said the common place for securely saving the application configuration. This application gateway, oh, okay, you don't see my screen. You can see my screen, right?
Yes, we can see.
Okay. Okay, the application gateway is it's a common point where all your websites, applications hits, and the request will be diverted internally to different services and servers, and the user, you will not know which server you are connecting from outside. Defender is Active Directory is just that logging mechanism. For corporates, it's just like logging into your email. You will be using an Active Directory login, which will be supporting a single sign-on kind of mechanism. So the same login you will be using to log into other applications such as Microsoft Teams, OneNote, etc. So that also gives a security. So you don't have to remember different credentials. And once you log in using some MFA method, it is secure. This I will skip. Defender is a anti-malware virus scanner kind of thing. Boston is a direct connection to particular servers. Azure DDoS protection is built in, but still, if you want to configure something additionally, you can do that. Like you can block a range of IPs. If you think from a specific region, some attacks are frequently happening, you can block that region itself. Azure Firewall Manager, this key vault for saving the keys and certificates, confidential ledger. These are all different topics. This URL also I have mentioned in the PPT. You can read about that more. With that, I think I am done. So I think we can talk. If you have some questions, we can discuss.
Praveen, this is Ramesh here. First of all, would like to really thank you for great session, really. So insight and so knowledgeable. Thank you very much. Now, I want to hear from you about one is the column level security and row level security, what you talked about.
Yes.
Is that we are talking about happening through application development?
So previously we used to control that using applications. We had no other choice. Okay. So when you log into a system, the database will have information like what kind of permission you have, right? Or for example, technically speaking, there will be a column in the database in all the tables, the customer ID. So you will be having a customer ID, and all the records with that customer ID will be shown. Other records will be programmatically hidden from you. But if you somehow, if you get access to get to know the number, or you can guess the number, for example 27, if there is a URL which takes 27, you manually change that number, there is a big chance you will get information of the other people. Now, very recently, within 1 or 2 years only, this row level security, column level security features came for these databases. Now, for example, that SSO or Active Directory, right? This kind of, these are open ID. So you will be logging in using a forms-based authentication. It's no more, the username and password is not anymore stored in the database. There, it will be handled by a authentication server or a API itself.
Right.
So that will act like a kind of impersonation. Okay. So when there is an API to read records from the database.
Got it. So if I can summarize,
you are accessing that API. That means only those records will be sent to you.
Right.
Another user accessing, only
he or she will get their data.
Only their data. Even if she or he is trying to manipulate the URL by providing some customer ID and all, he will not get. Always that once that feature is enabled, the database will make sure that the caller gets only his data. That's the idea. Now, column level security is also same. For example, maybe some payment details are also there. Your salary details. Okay, maybe some internal numbers are also there, which your employer thinks you should not be knowing that, right? So that if we set a column level security disabled for you, you will not get access to that as well. So it's a vertical and horizontal level of security.
Beautiful, beautiful. If I can summarize, my understanding is that it is an extension to your authorization concept. So at the time of right within your application, what I can do, so all my query and reporting, etc., what I'm eligible is associated to my authorization. So I will be seeing only mine. Beautiful. Got it.
Exactly.
And another question from my side, that Key Vault, Azure Key Vault service, what we are talking about.
Right.
Is there any instance from your experience that whether Key Vault has been compromised?
No. First of all, the Key Vault is not a database. It do not have the capabilities to store huge amount of data. So we will be storing only the database password, email password, that kind of highly secure stuff, and ideally less than some 2 MB of data only there. So far, in my knowledge, last 20 years, I haven't heard anything specific to that. First of all, this Key Vault is not exposed to public.
Correct.
So if you are an administrator, you will log into Azure portal or AWS portal, then only you can read that. So multiple levels of authentication required there.
Fair enough. I will put this question this way, that if my admin credentials are compromised, then there is a huge possibility of I have access.
Yeah, that is not Key Vault. Any service you can manipulate.
Got it. Great. Thanks, Praveen. So nice. Thank you. Manju, back to you.
Any other questions, anyone? Thank you, Mr. Praveen, for such a detailed, in-depth session, which benefited all of us. Looking forward to your next session, where we can probably take one particular topic and then discuss in detail. Thank you so much. Thank you, everyone, for joining, and thank you for the discussion. Have a good night. See you next week.
Thanks, all of you.